What if we change the volume? Well, if we change the volume of a gas, that's going to change the pressure, isn't it? If we decrease the volume, we increase the pressure. So you take a container of gas and you make the container smaller. You're squeezing the gas together, and so the pressure is going to be greater. And if you think about the concentration, are those gas molecules more crowded, more concentrated, or less? They're more, right? Because we squeeze them together. If we increase the volume, if we expand the container, the pressure goes down. The gas particles are more spread out. When they are more spread out, are there going to be more collisions or fewer collisions? Fewer collisions. They're all spread out. I've talked to you about Wyoming before, right? Population of Fresno in the whole state. Is Wyoming a great place to go and meet people? Probably not. Where do you go if you want to meet lots of people? You go to a big city, right? Where there's lots of people in a small area. And even there, you're not going to go to Central Park. You're going to go to a bar or some place where there's people, lots of people crowded together. That's where you're going to run into people more often. Not riding across empty pasture in Wyoming. When we lower the number of moles of a gas, we're going to get a lower pressure if the temperature and the volume is the same. Okay, so PV equals nRT. If N goes down and T stays the same and V stays the same, R can't change, then the pressure must change. If we take some gas out and the volume of the container is the same and the temperature is the same, then the pressure must be less, right? Because we took some gas particles out. So what can happen is if we change the pressure, the system can relieve that or fight against it by changing the moles of gas that are present. If you increase the pressure, it's saying, what can I do to decrease the pressure? If I decrease the number of moles of gas, then I'll decrease the pressure. If you decrease the pressure of the system, it will shift in a way to increase the pressure back. It'll shift in a way to make more moles of gas. Let's look at this reaction. You have nitrogen and 3 moles of hydrogen reacting to form 2 moles of ammonia. Among the reactants, we have 1, 2, 3, 4 moles of gas. And among the products, we only have 2 moles of gas. Because the atoms are combining in different ways. And so here we've got this, it's a little bit like carpooling. So here we have 4 cars, and each car has 2 people in it. And here we have 2 SUVs, and they each have 4 people, right? It's the same number of people, but this is going to take up less gasoline or something. I haven't really worked on this analogy much. Maybe you could tell. If we have this equilibrium in this container where we can adjust the pressure by changing the volume, if we squeeze this together, that increases the pressure. If we have more particles, we have more pressure. If we have fewer particles, we have less pressure. So if we squeeze this, it's going to shift to the right to make fewer particles. Because that's one of the weird things about gases. It doesn't matter how big the particles are. What matters is how many particles there are. And so it can go from 4 particles to 2 particles. That will cut the pressure down. And so when we increase the pressure, it will shift to the side with fewer particles of gas. If we decrease the pressure, if we pull up on this piston, we can cause the equilibrium to shift the other way to more particles of gas. Does that make sense? Now, so here's the other. We increase the volume, we decrease the pressure, we expand this out, and now these guys are going to spread out. they're going to make more particles of gas because they're trying to undo the change. These balances are weird, aren't they? They just go off and make noises. They're like self-adjusting or something. So this is the summary of all of that. If we decrease the volume, it causes a shift in a direction that has fewer moles of gas particles. Remember that decreasing the volume and increasing the pressure are the same thing. If we increase the volume, that decreases the pressure, causes a shift to the side that has more gas particles. If the moles of gas particles on both sides of the equation is the same, then changing the pressure is not going to do anything.
Can you think of it like if you decrease the volume, then you get more reactants and that way instead of gas particles, or?
Well, no, because you don't know which side is going to have more particles. So you can't say, well, if I decrease the volume, I'm going to get more reactants, because that will change from reaction to reaction. So let's look at this example. Here we've got 2SO2 plus O2 in equilibrium with 2SO3. All of these are gases. How many gas particles or moles of gases are on the left side? The reactants. There's 3. 3 moles of gas on the left, and how many on the right? 2. So they aren't the same. If we decrease the volume, I'm sorry, I'm moving my arms the wrong direction. The YouTube people couldn't even see that. If I decrease the volume, I'm increasing the pressure, right? I'm squeezing them together. Am I going to go to fewer particles or more particles if they're being squeezed together? Fewer particles. So this is going to cause it to shift to the right.
So whatever side has fewer particles, that's the side that it's going to go to?
When you decrease the volume, increase the pressure. When I increase the volume, which decreases the pressure, it's going to go the other way. It's one of those things that's a little bit hard to grasp. Are you grasping it? Should I try my analogy some more? Yeah? Okay. So we'll see how this goes. So trying to stick with the cars and the SUVs. So if I decrease the volume, so I'm squishing things together, the highway is very congested. Okay, it's squished together. There's lots of cars out there. Would it be better to take 2 SUVs or 3 cars when traffic is bad? Fewer vehicles would be better, right? And if there's lots of space, if there's hardly any cars out there, there's not much traffic, then you might want to take more vehicles because you have more flexibility. Somebody wants to stop, not everybody has to stop. See, that direction, it doesn't work as well, but you might want to spread out and have more vehicles. But when things are crowded, you want to get into fewer vehicles to save space. Did that help at all? A little bit?